Yeah, today is Saturday morning, about to be noon. Um, I went to the gym this morning. I already had breakfast. Relaxed for 30 minutes or so. So yeah, now I am going to either do one or two problems really fast, like 20. I'm aiming for. I always put a timer for 25 minutes. That's the maximum of time I'm gonna give myself for one. But in the case that I can complete one in 10, 15, 20 minutes, I'll probably do another one, just to do two problems right now in this session. But I will pause the video and then start another one, and these are going on my YouTube channel. To be honest with you guys, if anyone watches this, I'm not doing it for any other reason more than, um, one, to record myself and see how I am improving over time, because I'm a big believer in a growth mindset. This Leetcode, problem solving is a skill, and like many others, the more you practice, the better you will get. Um, so yeah, that's basically it. I just wanna see if I am uh, what to call speaking correctly, if I'm explaining my uh, my thought process, and simply just to see how I'm approaching problems over time, and see the ones that I struggle with, and the ones I'm getting good at, or the ones that I'm really struggling with and I need to uh, get better at, I guess. So yeah, like always, I'm using this website, Zero Track, um, .github.io. It's a website that has been tracking the problems that come up in the weekly and bi-weekly contests, and they are filtered by rating. That's what I'm using, my rating. Um, I I just think it's a better or a different way of practicing. It's much like in video games, you have an elo in competitive video games, and that sort of like determines who you play against and things like that. So my rating at the moment is like, yeah, 1439. So I'm kind of going. That's kind of how I'm doing this sort of like my training, I guess. So yep, I'm gonna pick one. But basically, other than the elo, I also look for high-ish acceptance rate. Anything about above 75%, I'll probably attempt, simply because the ratings, the acceptance rate, that is a combination of like how many submissions were accepted versus not. And I've noticed if it's too low, like below 70%, the questions most of the time, not all, but most of the time, are super confusing. The examples are not even there, or like they suck, if I'm being honest. A bunch of things like that. The constraints or the problem just doesn't really make sense. It's not good to practice. So that's kind of why I am, you know, filtering them by this. And I also did buy Leetcode Premium at some point when I had an interview for Meta. I had one like a few weeks ago. I failed it. Just needed more mock interview practice and stuff. But I will say that filtering by the company is good, and you can see, what kind of questions they are asking. However, yeah. Anyways, let's start. I think I'm gonna do this one. 75% acceptance rate. People are doing it, so I'm guessing it's more popular than the other ones compared to like for So yeah, I don't know. I'm just gonna pick this one for now. So like always, 25 minutes. I have never seen it before. I have never like solved it before. So yeah, let's go. There are n rooms labeled from 0 to n-1. Okay. So yeah, all the rooms are locked except from the first one. Your goal is to visit all the rooms. However, you can enter a locked room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number of you can take all of them with you to unlock the other rooms. Given an array. True, if I can. Okay, so rooms. I have to return whether or not I can visit all rooms. So yeah, true, false. Uh, first room. Oh my god, room is the only one. Oh my god, I didn't even start the timer. It's the only one unlocked, and uh, so gotta start there. Each room that I go into has a distinct set that open the other rooms. So basically, I gotta make my way through them. Okay, so my thought process is literally taking me through sort of like a graph, because not that they're connected, but I have to go into one so I can think of it as a vertex and to see where I can go from there, right? It's kind of that same process. But not really, because that doesn't mean that from this room I'm gonna be able to go to the other one. So it's probably not a graph, but that's just kind of where my mind went initially, right? Especially because some graph problems, like if you want to find a what's it called, uh, a cycle, you kind of have to like keep track of like where you're at, like which nodes you've visited and things like that. So that's kind of where I'm thinking. However, let's see. Based on rooms, right? I know n is equals rooms minus 1, right? So I want to basically see if I have n. I want to see if I have n minus 1. I mean, another thing is, yeah, I guess if I have 1, 2, 3, that, you know, that is it. Here I have 1, 3, 3, 0, 1. Okay, let's do the second example. 1, 3, 0, 1, 2. I don't care about the 0 if I'm being honest, but here I have 0, 1, 2, 3. I have 3 rooms, right? So I need 1, 2, 3, I guess. Yeah. Yeah, actually, no, it is n. So I care about n, 1, 2, 3, especially like that in order, right? So if I have those keys here, 1, 2, 3. Okay, 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 okay. Okay, no, I do think it's a freaking graph problem. Yeah, it is a graph problem. Rooms I are unique, meaning that I'm not gonna have a repeated room. So I guess, so what I was thinking was to just do a pass and get all the keys, and then just check if I have the ones to open all the doors, right? However, like in this problem, and again, this is why I do care about the acceptance rate, because some problems I guarantee you probably wouldn't have this example, but it's really good because um, it's literally showing you that this one would be false simply because the key to this room is in its rooms and there's no way to access it, right? We cannot get it anywhere else. So I'm thinking then that I have to basically do that, right? So I start in this one always, right? So this is my starting point. This is my first vertex. From it, where can I travel to? I can travel to 1, right? So I've done 1 in 0 and 1. I'm storing that somewhere. Then from 2 I can go to 3. So I go to 3. So now I have 0, 1, 2. And from this one, from room 2, I can go to 3. I go to it. Once I get there, I already have all those like visited, right? Even if I'm not like visiting them at the time, keep track of rooms you've visited to, number 1, avoid revisiting them, and 2, that will tell you when you are done. Yeah, I can just keep count of how many rooms I've visited, right? Yep. Um, so here I don't care about this one. I'm gonna do n minus one. So 1, 2, 3, 4 minus 1, 3. That's it. Because keeping track of which ones I've visited will sort of like stop me from going into another one, right? So that is it. So I'm gonna start with 0, and then yeah, if I can counter 0 again, that's not gonna happen. So that will work here, right? I can just do like a sort of like DFS approach, starting here and just kind of like visiting everything, and just keep track of a set. If I do a set, then I can just use the size to sort of like tell me. Now, if I'm here, let's see if this will work, right? So room 0, I added 0 to my set, equals 0, right? We have 0, so I can go to 1, I'm gonna go to 1, from 1 I can go to 3, so I'm gonna go to 1, 3, from 3 I can go to 0, I'm not gonna go again, right? Like I am gonna go inside it, but I'm not gonna, so I'm not gonna back out because it's already in the thing. Um, then from this one, the first room or the second room, whatever, the one room, I can go to 0 again. I already have it, so I'm not even gonna bother. Then I can go to 1. This is itself, and it's already here, so I'm not gonna bother. So I'm gonna come back. Now, from the 0th room, we can go to the 3rd room. Here, I already came to 0, right? So I'm not gonna do it. So 1, 2, 3, 4 minus 1, 3. I cannot. Like I went into 3 rooms. Well, here I added 0, so I do think I do need the 0 in case this happens. So instead, I'm just gonna check for n, right? So n is 4. This is n minus 1. So this is not. Yeah, this is not n. This is n minus 1. So that means that I didn't go into all the rooms. That's it. So it's easy. So it's a DFS approach. So the runtime of this would be, let's see, if I have n rooms and I'm going to, and this room has access to, and every room have access to every other room, and I'm visiting them, I'm doing n times n, so n square. Yeah, and the space is probably like n square as well, because I am doing that sort of like, wait, no, I'm not gonna do recursion, right? Am I? How am I gonna do this? Yeah, no, I am doing recursion. So I'm gonna store at most n rooms, right? Because I'm gonna go through them, and then when I'm done with all the rooms, I'm gonna come back. Yeah, so I think that's what it is, but I probably do need to. So I think I identified it was a graph problem almost immediately, which was good. Hopefully, hopefully I'm correct, right? But I think I am. Hopefully I'm correct. The runtime and space I think are also correct, but if not, and double check this. Study this more. Study this more. So this is already like an adjacency list, right? So I think I can just travel it, honestly. Let me see though how I wanna do this. I haven't done a graph problem in like a month or so. Let's see. I have an adjacency list. Yeah, I'm gonna do a DFS. Wait, why am I doing this? Just do it here. I'm gonna say if no, I do need. Yeah, sorry, I'm kind of like here thinking. So I do need the same thing, right? I need the list of like the adjacency list of rooms, and also I need a set integer. Of count rooms visited count, and I need int n. Okay, if Oh, and I need a current sort of like tell me in which list I am, right? Wait, sorry. I think I'm gonna. Yeah, no. I don't need the adjacency list per se. I am. This is my DFS. So here I'm gonna do a for loop through this, but for each of them I'm gonna do this. I believe, right? No. Okay, 1 second. I'm gonna start 0. Here I need this list, right? 1. From it, pass me. Let's loop through it, and let's do it for that. So yeah, I need this. I'm gonna do the 0. If from this room I can travel to a bunch of them. No, yeah, I'm locked by the first room only, right? Yeah. So I only need that list of rooms, and if the current occur, if rooms that get cur is in the set, that's what I'm checking. If the rooms visited, wait, why am I keeping visited? I'm just gonna do visited. It's easier. If visited that contains, we're gonna do rooms that get return true. Yeah, and also yeah, that we don't want to do anything here, right? And then also if visited the size equals n, return true as well. Otherwise, we're gonna go to each room and I equals 0, I less than room the size I plus plus, and then we're gonna do DFS rooms visited n and I. And if what do I care about this? About this, yeah. If I can never get out of here, then I'm returning false because this never happened. And I don't really care. Do I care if a room here returns true? I care about that, right? Like if that happens, I do want to stop. And then here, I just don't want to go to it, right? So I want to kind of like return, but I don't want to stop it. So if this ever happens, this is my constraint, this is when I want to stop, I'm going to stop. Otherwise, I'm going to continue. At the very end, I do return false. So I think I can simply do return DFS and then rooms I get 0. New set integer. Wait, new hash set. Oh yeah, this works. Is it? No. It's a new hash set. Set is the interface. Then I also need rooms size and 0. Right? Do I need that? And I also need to keep track of the visited ones. Hold on. So here I'm gonna pass 0, right? No, here I'm passing rooms. This is a list of numbers. Yeah, get I, like that. Yeah. If it's not, then I'm gonna add it, right? I'm guessing. Visited add cur, and then for each of these, this is happening anyways. Yeah. So let me do a dry run and see if this is correct. So let's start with the first example. Okay, I'm gonna get this list and I'm passing 0 and I'm passing a new sort of like set to keep the visited ones. And so yeah, I'm passing uh, I have not visited any of them. Visited is 0, so this won't happen. Visited contains we have not visited 1, right? Current 0. Is this correct? I'm checking for no. Cur. Yeah, that is correct. So I have not visited 0, so I'm gonna add it. So then my visited equals 0. It has 0. So then from this list, I only have one room. It's to 1, right? So I'm gonna iterate over the list. And then I'm gonna pass the rooms, right? I wanna pass. Ooh, I need the adjacency list because I'm gonna need to go to that one. And then I also need to pass that current one, right? Or wait. Yeah. So this is fine. Like that. Yeah. So here, instead of passing, I'm passing rooms. And here I'm passing room. I'm passing that list. Get. And this is room size. Yes. Ugh, I think I don't need to pass this one. Hold on. I have access to rooms. By current one, I know which one. Yeah, I don't. So yeah, this is giving me my list. I'm passing rooms, and I'm gonna get cur. Wait, I think it's better if I actually get just the room. And I can do that. And then here room that get the index. Yeah, this works. So 0, it's gonna I'm gonna add it. I'm passing the whole rooms. I'm passing 0. 0 hasn't been visited, so I'm gonna add it, right? Then I get the room, so 1 or keys or however I wanna call it. With keys, honestly, yeah, that makes more sense. Then I'm gonna iterate through them, right? So then I'm passing all the rooms, right? Because I need them. I'm passing my set of visited, which now has 0. I'm passing n to know when to stop. And I can probably do rooms that size as well. Minus, yeah, no. Yeah. And then I am passing that keys. This is 1. Yeah. So I'm passing the number. Right? So then it's gonna get this one. Here. So visited size, no, if this isn't true, I only have 0. Yeah, I have 1. The current is 1, right? Keys that get 0 is 1. So I don't yet have 1. So then I'm gonna add it. So now I have 0, 1. I get my keys, which is just 2. The same thing happens. Now I pass 2. Same thing, this does happen. I'm gonna add 2. And then I'm passing that. Then I come to 3. This is not yet the thing. The the constraint. I have not visited 3. I'm gonna add it. And then I wanna stop. Do I wanna like check this first and add it and then stop immediately? Yeah. Wait, no. Yeah, this is correct. Otherwise, I already said that I visited, and if that meets... No, but it does make sense, right? Like if I can go to 3 and I already met this... Well, but I could go, and then by here I can stop immediately, right? Because I'm already full. Yeah. Yeah, I think that works. Okay, let's just do this one really fast. So I know that the first problem works. I have a few minutes just to check. So 0. So yeah, I'm gonna add it, and then I go to 1. I'm gonna add it. Then I go to the first one, 3. I'm gonna go to 3. I'm gonna add it. Then 0 is already there, right? Here. So I'm returning false. So then 0. I'm returning false. 1. I'm returning false. Then we come back. We already did 1. So now we're gonna go to 3. 0. Returning false. I'm done here. I don't have anything else. It's gonna get here. It's gonna return false. Yeah, that works. So I'm gonna run it. Okay, let's see. A list of lists of integer rooms. I have my set integer visited. Oh. Rooms. I didn't edit this. Yep. Yep. Rooms visited get Trojan true. I didn't boolean. Huh? Am I doing something wrong? Let me see. Oh my gosh. No, wait. Dude. So sorry, you guys. And I'm missing that. Let's see if I'm missing anything else. Zero key size, plus plus, and the rooms visited. Keys that good. I'm always getting that one. Yeah, yeah, this should work. Huh. Alright, 0. I'm adding 0. Then 1. I'm adding 1. Then 2. I'm adding 2. Then 3. I'm adding 3. And then it comes here. I already know that, right? I already added 3. Visited as size is 4. Rooms as size 0, 1, 2, 1, 2, 3, 4. This should happen. No? Let's see. 1, 0. Passing 0 here. Visited is not equals. Visited doesn't contain, so I'm gonna add 0. Then we pass 1 here. Keys that get are 0. Then yeah, this is not true, this is not true. I'm gonna add it, so now I have 1. And I'm gonna go through the keys here, which is 2, and I'm gonna pass that. This is the only one. So this is not true, this is not true. I'm gonna add 2. And I'm gonna pass through all the keys, which is 3. And I'm gonna go to 3. So this is 3. It's not true. Not true. I'm gonna add it. and I'm gonna go through the keys. I don't have any, so this never gets executed. Ah, okay. So this thing I do think needs to be below, right? But do I want to say that I already visited? If I already, yeah, that means that I already visited it, right? Yeah, I think this solves my issue, at least for this example. But if 1 goes to 2, 2 goes to 3, I'm already claiming that I visited 3, and then I'm gonna go to, yeah, I don't want to visit it anymore because I'm here. Yeah, no, that makes sense. I think that was my mistake. Let me just come up with one really fast. But yeah, I just hit the timer, so I'm still within time, I think. Plus, I just wasted time explaining at the beginning. So let's say that I have the 0 room, the first room, the third room, 4, 5, 6, 7, 8, 9, 10, right? And all of them are separated by commas. And let's say that from this room I can go to 1, from this room I can go to 0 and 2, from this room I can go to the 5th room, 0, 1, 2, 3, 4, 5, from this one I can go to 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. From this room I can go to 8 and 9, and from these rooms I can go to other ones that we already went to, and these rooms don't have any keys. That should be true. Yep, okay, it works, I think, unless there's an edge case. Yep, good. So I think that was good. I do want to kind of see if I could have done anything better. I honestly, what? Boolean visited. The numbers are unique, they said, right? Okay, this doesn't really matter, I think, that much. Yeah, here I can return. I don't need void. Yeah, I guess that, yeah. List of what? Rooms. Hmm. It's a different way, a little bit better. Like a tiny bit, just simply, probably because of the array. Um, but this is not even getting initialized. Oh, okay, here. Yeah. Okay. I mean, I guess I did think of the graph right away, which it makes me feel good. But yeah. Anyways, definitely was a little bit like overthinking. Not that what's it called? Confident in my solution, but I solved it. Took me a little bit over 25 minutes. I know. So yeah. Okay. Done. Bye bye.